So in the last video, we talked about economic growth. In this video, we're going to try to find the source of economic growth. And quite simply, it's largely the differences in real GDP per capita across the country or across the world are largely due to differences in worker productivity, in productivity of inputs, more generally speaking. So if we take a look at this graph down here, where instead of having real GDP per person, here we have real GDP per number of workers, per number of people employed. So what we're looking at is income per worker, which is really a measure of productivity, okay? We're really looking at how productive the average worker is. And so if we look at this bar graph, well, we're seeing the similar trend that we saw for real GDP per person, not per worker, per person, where we had a lot of our African countries further down the distribution. And as we go up the distribution, we start including more countries, more South American countries, more Asian countries, starting in even on some Middle Eastern countries. And then we start seeing, as we continue moving up, then we start seeing some of our wealthier countries that are in Europe, some of the richer Asian countries, and then we start seeing the wealthier European countries and North American and the richest Middle Eastern and Australia. Okay, so what we're getting at is that there's a pretty strong, we'll call it an association. We won't make it causal just yet, but a strong association between productivity and real GDP per person. So essentially what we're saying is countries that are more productive with their inputs are going to have higher standards of living, which should make sense. So in looking at that and trying to understand that, we want to really plot how efficient countries are, like how much output they're producing given certain levels of their inputs. And that's what this thing called the aggregate production function does. It highlights the relationship. It's a relationship. It's a function. Anytime you see the term function, it should be a relationship. And it is a relationship between inputs and output. Okay? It's the relationship between our inputs and our output. This model has multiple inputs. The aggregate production function is generally stated. There's not a specific functional form given to the aggregate production function. Okay? All we say is that it is some function, some relationship between capital and what we call efficiency units of labor. A lot of times I'm just going to call it labor. But basically this production function just shows the relationship between these inputs and the resulting output, represented by real GDP. Okay? Importantly, output is your dependent variable. So output is going to be determined by the other independent variables and something that indexes for technology. Our independent variables, again, are going to be labor and capital. Specifically, labor is going to be how efficient that labor is, the number of units of labor, how efficient they are, and how much capital stock is available in the economy. Not an independent variable, rather an index, is this A, which represents the overall level of technology in the economy. Okay, this A represents the overall level of technology in the economy. So we have two inputs, human capital and physical capital. That's why this is H, is this total efficiency units of labor. A lot of times we'll call human capital as well. We have these two independent variables or two inputs that are used in the production function. They are used, and the efficiency at which they are used is represented by technology. Okay. All right. So we've been talking about. Let me expand upon this a little bit more here. Well, again, human capital, physical capital, we're already pretty comfortable with. We've already talked about what physical capital is. We talked about human capital is a little bit. Let's expand upon it a little bit. So human capital, again, it is the amount of labor available in the economy, but it's also measures how productive that labor is. Okay. And so the way we convert this is we have L is the total number of workers in the economy, the number of people that are employed. And then this H, this lowercase h, essentially tells you how efficient that labor is. Okay. So this is kind of like, it's like a human capital index. Okay. It's another index. It's another scaling measure, which tells you essentially how much useful input you have in the form of labor in the economy. Okay. And the way you increase human capital is through either one, education, going to school, or two, and still education, we just call it on the job training. Right, that's how we increase our human capital. Again, technology is just it's used as an index to determine how efficient the production process is at turning inputs into output. Okay, how efficient we are at turning inputs into output. So technology, generally speaking, is just the process of turning inputs into output. So when we have this index, this A from the previous slide here, this is just indexing how well we turn those inputs into output. As far as the functional form is concerned, like what is the shape of the function? Well, remember that it is there's two independent variables, and so the relationship for those two independent variables of labor and capital is one, more is better, meaning that the marginal products, and we'll discuss what that is in a second here, the marginal products are positive. Okay, so what that means is that there's going to be an increase in GDP for a 1 unit increase in physical capital or labor. Okay. Right. So if there's a marginal increase in one of the inputs, it will lead to at least some positive increase in output, in real GDP. Okay. Positive relationship. And the second part is, or the second condition is that while the marginal products may be positive, they are going to increase at a decreasing rate. There's going to be diminishing returns, something we've talked about before. Okay. So, and specifically, there's going to be the marginal contribution, or the marginal increase in output is going to diminish as we use more of an input, but importantly, holding the other input constant. Because we have two inputs, the way we're going to model the aggregate production function is by holding one variable constant, and then one independent variable constant, and then showing how output changes with an increase to the other input. Okay. And so just to highlight, before we actually draw and map this aggregate production function and show you the actual shape, let's kind of unpackage this idea of a marginal product a little bit more. The marginal product is, again, just associated with the additional output from a one unit increase of an input, okay? So both capital and labor, and I'm going to use I should have highlighted this, the German spelling of capital again, because we're using K for capital. So what this means is that if we want to increase output, yes, we're going to increase output, but if we are trying to increase output by increasing our inputs, we're going to need an increasingly larger amount of inputs to get the same increase in output. Okay, so this is similar to the diminishing returns relationship we've seen before. So this shouldn't be anything too unfamiliar. Okay, so let's actually let's see what the shape of our aggregate production function. Now, again, remember that we are looking at, because we have two independent variables, usually we just have y, y is a function of x. Well, now we have, y is a function of two variables, let's say x1 and x2. Well, now it's just that this y is now as a function, accounting for technology, now is a function of these two variables where x1 and x2 is just labor and capital. But to measure this, because we have these two independent variables, we got to hold one of these variables constant. So like the amount of labor in this case is held constant. The number of people working is held constant. And what we're mapping is how physical capital, when there's an increase in physical capital, how much of an increase in output, Y, real GDP, how much that changes given an increase in capital. And so we see, again, there's diminishing returns, where if we look at point A and point B, we see a 1 unit increase in physical capital stock. Notice that if this represents this horizontal distance here in green represents a 1 unit increase in capital. We'll notice that the increase in real GDP, let's say it goes from Y1 to Y2, we'll notice that's going to be bigger than the increase in real GDP when we go from, let's say, Y3 to Y4. Okay? What we're saying is that this vertical distance, the increase in output from a 1 unit increase in capital at point A, well, that leads to a larger increase in real GDP than when we increase capital, have a 1 unit increase in capital when capital level is at point B. So again, diminishing returns in capital, holding labor constant, and if we hold capital constant and let labor change, we see the same relationship, the same diminishing returns relationship. So there are diminishing returns in both inputs, capital and labor, in the aggregate production function. So that's how we draw our aggregate production function. In the next video, we'll start talking about how we can grow the economy, how we use this model of the economy, the aggregate production function, how we can use it to show how to grow the economy overall.